What's weird is not only do most other stars have their own planets, but they also have a specific type of planet that we don't have in our solar system. And that is a super Earth, a planet that can be up to about 2 times the radius of Earth, or a sub Neptune, which is a planet that'll be a little bit smaller than Neptune. It blew my mind so much, I decided to get a PhD in astrophysics. Obviously, in our solar system, we have an Earth and a Neptune, but most systems have a planet in between those sizes. Super Earth is basically going to be a larger Earth. It's just going to be a rocky planet that doesn't have a significant atmosphere. But as you get into the mini Neptune range, you realize that there's still that rocky core, but on top of it, you have a bunch of gas: hydrogen, helium, methane, CO2, that type of thing. What's even more interesting is not just that we're missing the planet smaller than Neptune, but larger than Earth, usually found inside the orbit of Mercury, which is to say that the super Earth or sub Neptunes that we find have orbits less than 100 days. That's the most common planet that we find in the galaxy. We don't have anything like that in our solar system, which is weird. Now, we don't know why that is, but it might have something to do with Jupiter. Imagine the young solar system. There's this huge accretion disk of material that's orbiting the young sun, and planets are forming. And as they get more massive, they have more gravity, they're able to eat up more stuff. But importantly, planets that get an early jump in the disk can suppress the growth of other potential planets. And we know that Jupiter was the first planet to form. Also the most massive. This tells us something. Imagine Jupiter and Saturn. They form first. And what large planets tend to do in a disk is migrate inwards. And you could think about this because you have this enormous planet and it's moving through a disk, which is slowing it down a little bit. So it's going to tend to migrate towards the star. Luckily, it doesn't migrate all the way in. Saturn tugs on Jupiter a little bit and helps pull it back out to the outer system. Essentially, Jupiter not only siphons some of the material from the inner disk, but it also cuts off access from any flow of material that would come there later as these other inner planets are forming. And then what you end up with is 4 smaller inner planets, and then we have the ice giants a little further out. This is called the Grand Tack model, and we think it's why our solar system looks the way it does. Jupiter could explain why none of our inner planets reached these large sizes. It's hard to know for sure, but this seems pretty compelling to me. If I had to guess right now, I would say that Jupiter is the culprit for why our solar system doesn't look like the majority of systems that we find.